And we're back to the next lesson. Let's make this some different color. Can be, oh, it's not different. Can be like this. Right, so in this lesson, let me save it version 4. And yeah, all right. What I want to do, I want to create the trails from the it's looking like a sparks bus, but with trails. It's not the smoke or fire trail from the flying fragments like we did. It's just the small flares or sparks which are moving from the center of explosion and create the smoke trails. So in this case, we're going to use another version how we can create some kind of effect, because we already work with geometry, we work with the volume simulation, we work with the particle simulation, and now I want to combine the particle simulation with the volume, but without pyro. In this case, we don't need to use simulation like we did with fire and explosion. And the method how we can create the trails, they look like it's like smoke, the very thin smoke trail from particle. Many years ago, when I just began to work with NFX, I began with 3ds Max, and the main tool for creation, the FX creation for the smoke or something before many people go into the FX was the Afterburn plugin. And the Afterburn plugin works pretty good because it doesn't create simulation like we know. It's creating particles. Well, we create the particle simulation, and based on each particle, we make a sphere with some volume noise inside. So if you want to create a smoke trail like from rocket or something like this, we need to create a particle simulation from the engine of this rocket, and then put in based on each particle, put a sphere. The sphere was with a different size, with a different noise inside. We can stretch those spheres so they can be, rescale them in different direction. So it will look pretty nice. And the main advantage is that we don't need to create any kind of simulation except of the particle sim, because at that time, was computer like a 4 gigs RAM, and even if FilmFX existed at that time, we can't create a large-scale simulation using FilmFX because we don't have it, the RAM needed for this. But if you create a particle simulation, we don't need to create a container or something like this. And the main problem was the proper render setup, because if we increase the quality of this, of the densities of those smoky spheres, sometimes render time was incredibly long. But anyway, the main principle of simulation we will recreate for now. So we need to take our particles. Again, we can use the same source we create here for our, let's call this sparks. I don't know why I'm definitely remember that I want to name it. No? Okay. So we're going to use the same source. We're going to apply the same, I guess, almost all those things we will recreate again, maybe with a different setup again. And I guess that we will use those particles to emit other particles, like a trail particles, and just convert them into the volume. Like we create a source for explosion or for fire, we convert this into the fields. But in this case, we won't transfer those fields into the pyro system. So let's copy this again, the Explo-Geo. That's what we are. Actually not. Let's go and copy my Explo points. So I should have somewhere, yeah, there you go. So let's copy my Explo points here. Explo point 1. Let's remove geometry. So we're gonna keep just points. Let's go to frame 25. As we know, somewhere here. Oh yeah, I need to auto update. So somewhere here we have a sphere. So let's delete geometry and keep the particle. And what I want to do, I want to create using the pop replicator, sorry, not pop, point replicator. Pop replicator is inside of the pop network. I want to use a sphere around this particle, so it will generate some particles in the same position. Let's make a seed with $f, oops, sorry, $f, to change the particles in each frame, so we can see those particles exist till the end of our frame range, because we not apply our blast for now, where we remove our particle in the next frame after explosion. So let's add some noise over here. Let's maybe change the frequency a bit and the amplitude. Not too much. Something like here, something like this. So, and with attribute, we need to copy source attribute. I want to transfer my explosion frame and all other things here. Also, I want to transfer my normals. So let's set it here with my normals. I don't have them, right? Maybe I need to look at the explosion animation here. Where is my normals? Where they are. So attribute triangle, copy the points. Let me remove normals from this. So now I can definitely should have a normals. Right. So normals I want to use for getting the direction for my explosion. In this case, it's not explosion, it's like particle explosion, you can call it. So I transfer my normals from here, because you can see there's something wrong with them. When I try to use a point replicate, so the next thing I need to do is I want to apply the same attribute WAP for creating a proper velocity. But before I do this, I want to remove my particles after the explosion frame. So let's name it H particle, let's call it H. But in this case, I don't want to add the H attribute, and then I can, remove particle if my H will be equal to, or will be more than like 0.2 or 0.3. In this case, I want to remove my particle not in the next frame after explosion. I want to make those particles leave some frames. So let's say if explosion have on frame 25, let's remove them on frame 29. So they will exist 4 frames after explosion and will produce those particles. So how we can do this? We don't have the H here because, it's not a particle, it's actually a point generated with the point replicate. All right, but how we can, what we can do in this particular case, we can take our explosion frame attribute. So let's bind, and I need to make sure that I have this attribute explosion. Yeah, explosion frame, I have it. So in this attribute is, by the way, the float. We can definitely need to create it integer, but anyway, explosion, it's very important to name it properly because it won't work. So in this case, we have the explosion frame at 25. How we can create some kind of counting frames after explosion? So if we go to frame 21, if we go to frame 25, in this frame we create those particles. In the next frame, frame 26, we can compare current frame with the explosion frame, and we can understand how many frames this particle exists. So if we take take the current frame, which is by the way over here, and subtract it from the explosion frame. So in this case, on frame 26, our points will have the value of 1 with this operation, because 26 minus 25 just for particles or just for points with the explosion frame 25, right? So in the next frame, they will have the result of this subtraction will be 2, 3, 4, etc. After the next explosion, some particles will have the explosion frame 46, and they will create their count again. So because the 48 minus 46 will be 2, and etc, etc. So for each group of the particles or group of the points, we will create the different result for subtraction because they have a different explosion frame attribute. So, and what if we have less than 25 in this case? If we subtract, it will be the negative value. So somehow we need to kill the negative values. We can do this by two different ways. We can go and clamp. We can make a clamp. So we need to say that the lower values will be less than 0 will be 0, and less than 1 will be 1, because of 1 will be 1. But in this case, I don't know, sometimes we we don't have understanding how big this maximum value should be. Okay, maybe it should be like 10, 20, 100. So we can simply remove or select just values bigger than some, threshold. In this case, I don't care about the maximum value. I take care just about minimum value. So we have the maximum node here. So if I plug my input, or actually output, from subtract to this maximum into another input, I don't need to just apply the constant. I don't want to have this parameter outside of this node. So if I connect 0 here, in this case, we will in the output, we're going to have the maximum value from both inputs, here or here. So if the subtract result will be bigger than 0, it will go to the maximum because it will be bigger than this constant value. If the subtract result will be less than 0, then 0 constant will be maximum in this case. So anyway, from our max output, we're going to have values just bigger than 0 or zeros. Okay, so we're going to look at the maximum value from the both input. Then let's go to the fit range, and in this fit node, we will select the life of our particles, our points. So how big value should be here in the source mark? So how many frames I want to keep my points in the scene and then remove them. So if I type here like 4, it means that if the value going from the max node will be bigger than 4 or equal to 4, the shift amount will be 1. The value closer to 0 will be a 0. So if our points not exist in my scene, so we need to understand that till frame 24, we will have 4 particles generated from frame 25. The value will be 0, and it means that our fit node will output the 0 values. On frame 25, okay, those particles again, they will add a 0 value. So we don't want to do this. In this case, 0 means that we will remove our particles from the scene, but I don't want to do this. So what we can do is take our explosion frame and just using the subtract constant as okay, and let's subtract a little bit. So let's minus, I don't know, 0.5 in this case. So it means that we compare our frame with explosion frame minus 0.5. This means that on frame 25, our explosion frame will be like 24.5, 24.5, and our subtract will create for us the 0.5 output, and 0.5 output will be bigger than 0. It won't create a 0 result. It will create a result like 0.15 or something like this. So the idea is all values less than 0 and bigger than 1 will remove our points. So now the thing is, our points will exist between frames 1, 2, and 3. In frame 0, we remove points. In frame 4, we remove points. Okay, and that's why I subtract a little bit from my explosion frame, because I don't want to remove my particles on frame 25, because 25 minus 25 will give us 0, and that's how we can remove our points. So that's why I subtract it a little bit. All right, so now we have a range between 0 and 1, and we need to say that, okay, if I have values of 0, let's remove it, and values of 1, let's remove it. So we need to compare result, and compare a very simple system. If you connect it here and say equal to 0, okay, we have a Boolean output, which means true or false. If our value will be equal to 0, it will set 1 or true. It will be not equal to 0, it will set false. The same stuff I want to make for the value of 1. If our value 1 is 0, it will, so value of 1 go in here, it will output 1 from the Boolean because it's true. And in this case, if we want to use the both conditions, or frame 0 or frame 1, we need to use the OR function, or this input or this input. So if any of those compare nodes will generate the true or generate 1 from our output, it will generate 1 from here in any of those cases. And let's add the if block and add a simple operation. So we have a condition, and now we need to set the particle number. So we need to understand which particle has those values and remove points. So if our, let's connect the ptnum, if our particle have one of those values after the fit node, we will remove them. And that means that our frame will be or 0 or 4. But if this frame is between 0 and 4, the particle will exist. So let's go to particle age and let's look at this. So if you go to frame 25, somehow it doesn't look, so maybe -1. Oh, sorry, I need to, okay, and you subtract, I need to add values. Oh, you subtract, sorry. Right, I'm doing the right thing, but not with negative values. I need to set just 0.5 because we create the subtraction, okay? So I don't need to set minus here because minus plus minus will be plus, okay? That's why, the reason. There is very simple math, but I make a mistake. All right, so now we have the particles on frame 25, 6, 7, 8, and that's it. So 1, 2, 3, 4 frames. 1, 2, 3, 4 frames. Cool. That works. And the same stuff for any other particles. So in this case, you can try to create some kind of age attribute. So if we take our, if we take this maximum value here, we can say that let's bind export, add a bind export, and call it age with a float value. And if you go here to geometry spreadsheet, now you can see that our particle had an age, but it's not correct age because we need to divide it by 25 because it's like an age of from frames. But anyway, we can create some attribute, and if we not remove those particles over here, we can remove those particles using the age attribute in anywhere there. You can simply set like an attribute wrangle and say if my age, current age will be bigger than, let's say, 5 frames, let's remove particle. So it's up to you what system you can use. In some cases, if you want to keep those particles or points for some other reasons, here you can just set the age attribute for those. You can even divide it by 24 and you're going to have the proper age. All right. and not using this, all this thing, just create an H attribute and remove by the H somewhere here, or you can remove it exactly here. So it's up to you what system you want to use. In this case, I think that this system will be a little bit interesting. So the next thing I want to do is applying my so where are you? The fire trails, no. Point jitter, the attribute randomize, the scatter. Oh, and just to understand, like, let me stop it for the moment. I want to, okay, let's create a speed again with the next attribute warp. And using this attribute warp, what I want to do, I want to create the velocity vector for my points. I'm going to use this velocity vector for the pop network. So set velocity vector. I'm going to use a very simple system where I use this kind of, we already know this thing because we created this with explosion. What I want to do is, using the bounding box, I want to take the center of my point group, take a file, using the add. I don't need to explain this again because we already did this. A divide by constant value, divide it by 2. Then using the subtraction, subtraction, let's take the position of each point and the center of those point group. Let's normalize them. And if we send this into velocity, let's send it into normals just to better visualizing. Go to frame 26. You can see that our normals is going from the center, which is good. Now let's set the multiply node. I need to set a multiplicator if I want to make those vectors bigger or smaller. Let's call this velocity multiplier. Let's copy this guy. Let's set it 1 by default. Also, I want to have an ability to correct the direction because I want to have direction more y-axis. But in this case, I want to use the direction from my normals because, as you can see, I transfer normals from my point setup. So it's like looking here, bam, bam, bam. Okay, so I can take my normals. Take the normals. I want to set the multiplication for normals also because I can, make them bigger or smaller also. So let's say 1 and normals multiplier or normal multiplier. And now I want to take those normal and set the add. I want to take my normalized velocities and add those velocities to the normals I have. So in this case, if you go to frame 26, you can see that they again looking upward. But if they're looking upward mainly, but now you can see that we have some kind of transition between points in the bottom area where we have the almost horizontal direction and why I don't see those guys here. Oh, because it's small or what? Yeah, here we go. So I have velocity multiplier and normal multiplier. So that's how I can correct my velocities. So I can move like velocity, make it bigger vectors, or I can control how many directionality I will use for my vectors. So let's say like I'm at 35 and you can see it's, whoa, no, it's too much. Let's take 3.5 and, oh, sorry. Let's set 35 here and 3.5 here. So it's looking like this. Oh, come on, sorry, my mouse. It's very big, but let's reduce maybe a little bit. And it's bam, 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 bam. It's normal, so we need to transfer them to velocity, definitely. So velocity going to have a little bit less, smaller vectors, not such a very big. Okay, so now we have a proper direction, and also we have a little bit of, you know, some tools which can help us to understand which direction I want to use in this case. So we can see that we can correct this more directional or more like an 360 direction from the particles. Okay, so now I want to copy, okay, point replicate, let's say C+3 just in case I don't want to use the same particles. Now I want to copy, I think those guys, the point velocity. Well, let's use the point jitter, velocity, pop network, all those stuff here, and let's add it here, because mainly we're going to do the same. So with the point jitter, we have a seed also. So in fact, we can use and this seed and this. So let's set like a 40. So with the same values. With the point velocity, I guess I'm gonna leave it as it is. With attribute randomize also, with attribute delete and all this stuff. So now I'll go to pop network, and that's gonna be my trails original point. So they will produce the trails. So it's like a parent for all other points in our case. So I'm gonna leave the same setup almost, but I'm gonna increase the pop drag a little bit. So let's set to 0.06 here and maybe 0.4 for the maximum value. And let's change the IDs like 0.40. I'm gonna leave array resist for points which will fall down. I guess they won't, because we're gonna kill them. We're gonna kill those points at some time, but in this case, how long they live, 0.5, 0.3, I guess we can leave it by this moment. If we want, we will change this later. Okay, so what we have at this stage, let's look at that. Bam, come on, let's look from camera. Let's disable this guy. Oh, we can enable velocity because it's more looking like trails. Bow. Bow, bow. It's looking interesting. It's looking not bad, in fact. Okay, so this is my trails. Now I'm gonna use those points to generate the trails. All right, so what I'm gonna do, I want to use those points as a source from the points from another DOP network. So let's add the pop network and connect it over here, and use the same the points, all points, use all points, but I don't want to have too much velocity from the original particles, so that you can see it creating some kind of trails on this. And but you can see that there's not too many particles in this situation, and the reason because we have not too many particles is our substeps. So if I increase the substep from 1 to, let's say, 10, we can create more particles from this. But even this method sometimes can create a weird result, and you know, is not like 100% what we want. We can't, you know, create, or it's hard to create the different position for those particles, because they use position from the points here. So if this point, original point, will move in one direction, just a linear movement, it's hard to create like a noise for those particles. So in this situation, what we can do is, using this amount of particle, how we can produce more points. So in this case, our particles, they create like a path. So they're moving to the with the original particle. Let's I guess let's add the Well, let's simply add a pop drag without any vex. So the pop drag, let's add like 0.3 for particles, and that will stay in the position almost. You can see it's slightly movement, and that's it. So what we can do is we can connect those particles with the line. So we can create a line between those points. Let me add the gravity force also to, to have some effect on those particles. But well, let's accept the gravity. Let me add the force. So with the pop force, we can create some kind of amplitude, 0.5 with a field size of 2. Bam. Well, it's not too many effect. Double it. And just a bit motion they should have. Let's increase the pulse length. And the most simplest way to create lines or primitives between the points is using the add. The add node is, from the first look, it's very simple, but it's really powerful node. So we can create the primitives using the pattern or using the group. So if we use the group, you can see that we create primitives between all other points from simulation. But we need to create some kind of order. I want to create lines just between points in one original, so from one parent. So how we can do this? We can do this by the attribute. So if you choose by attribute, we need to have a point, we need to have an attribute which will identify our points generated from the one original point. So if we type ID, it will not work because we don't have the same IDs from the particle. Let's say sometimes we can create like a sparks if we use the time offset or time shift, this case, and we can $f -1. We can do this and then merge. Oh, come on, merge those elements. So we can create the primitives between the same point from the last frame. So we take the position of all points from frame 33 and take the same points in frame 34 and merge them. So in this case, we have like two group of points, and in those group we have the points with the same IDs, because if we look at the point number, they will be different. But if you look at an IDs, go to geometry spreadsheet. Where is my IDs? Let's visualize just an ID. So now you can see that we have 2 points with the same IDs, 0, 0, 1, 1, 2, 2, and so on, because we have the same points just with 2 different frames. And we create a primitives between point in position the last frame and the point in this frame. So sometimes I create a sparks using this method, but in this case, somehow we need to create the same ID for each point generated in the pop network 2. Let's call this trails. Okay, and just from one point from the original. So all points generated from, if we look at this, let's say we have this particle, okay? And if this particle have ID, let's say 2, and all those particles produced with these points should have the same ID 2. So how we can do this? Some attributes we use in our original points, we will transfer. So if, let's say, for our original, we say different colors for each particle, then each particle in the next dot network will have the same attribute, because by default in the pop source, we have the inherit attributes star. So it means that we inherit all attributes from our source particles. But in this case, attributes which we create inside of simulation will be different. So in this case, our IDs, age, and all the things will be different. So to make it work, how we can transfer our ID from one network to another one? We need to rename it. So if I set the attribute rename, and let's, oh sorry, not remap, attribute rename. So let's rename the current ID to the old ID, to old ID attribute. Yeah, from points. So now if you go to trails, we have geometry. Come on, let's go to some frame 25, 26. I want to reset simulation just in case oh, come on, it's freezing. So I will reset simulation. And then you can see that I have ID and old ID. ID and old ID. So if you compare those IDs, you can see that the this ID is actually IDs from the original dot network, from the second dot network, but the old IDs is from the first dot network. So you can see that the particles created from ID 0 will have the same ID 0. Particles created from ID 1 will have ID 1, etc., etc., etc. So now if I'm going to use the add node and create the primitives using, in this case, the old ID attribute, you can see that we create the primitives just between points with the same old ID number. So we create lines for like those original particles. All right. So now let's convert them, because I want to create, we create the primitives. In this case, I want to convert this into the curve. So let's select, can use the Bezier curve. We can use the NURBS curve. I guess the NURBS curve a little bit better. So now you can see that we have the curve. We have a bunch of attributes. I guess I will remove them later because there's a lot of attributes I don't need to use. And then I need to create a resample node. So this method is a little bit more interesting if we want to separate, if we want to create a lot of points in the trail of each original particle. So with the resample, as you know, the resample node allows us to create a bunch of points on the line, okay, in the path or on the line. And in this case, we can use a 0.05 to create many different points. So the difference between the way we can create the points amount in our DOP network using the substep, and this is very big, because in this case we can do with our curve what we want. We can resample, we can apply the noise, we can make it line bigger, smaller, and etc., etc. So, and it works much faster than we create, you know, like 25 substeps in our DOP network simulations. All right, so now we have many points, and I think we don't need to change here nothing more. And I'm gonna use those points for creating the volumes. So again, I don't need those core anymore. I can use the add node again for removing geometry and keep the points. So in this way, I'm gonna have just the points. So you can see closer that here I have curve endpoint. This I don't have those primitives, I have just points. But from, you know, from this view, it looks like line, you know, without any points here. But those lines look very linear. I want to add a little bit of noise. So the best way to add the noise, well, we can use the attribute noise, but in this case, let's go noise over position. So in this case, I'm going to use the maybe anti-aliasing noise. And if we're going to take current position of each particle here, let's apply this 3D noise to position. you can see that, well, you can increase the frequency anyway. You can play with this. And maybe lower amplitude. You can see that there is something happen with our points here. Because we need to add this noise. Okay, we apply noise for position, but we need to add this noise to current particle position. So that's what it should work. How this should work. Oh, come on. But here you go. Bam. All right. But in this case, I want to use the current position for my noise. I want to use the rest position from my original particles. So if I said that I'm going to create a rest attribute, which will be equal to the current position of my original particles, I'm going to have this rest over here. You can see it, have a rest. So what if I'm going to use this rest attribute, which is vector, to generate my noise. And you can see that it doesn't work. I need to reset simulation because somehow there is a lot of zeros. So I reset my trail sim to properly transfer my rest attribute. So now if I apply this, now you can see that our noise is moving with this rest position because we use this vector. Maybe it's a lot of particles. I need to make them a bit smaller amount. Point replicate, the size, and I don't know how many particles I want to create. Let's say 75. Say 50 maybe. Bam. Yeah, 50 I guess can be a little better. Okay. All right, so we have a noise and we have those trails. We can do another one thing. We can multiply the amount of this noise to the age of our particles. And what does it mean? That we can decrease the amount of noise for particles with a low age. So what we can do is we can set a multiplicator, so we can multiply our noise by the age. But with the age, we need to create some kind of fit node. So let's say fit range. Let's take our age from particles. Let's say the source max like 5 and go to 0. This means that if our particle age will be closer to 5, it will be almost 1, and it will multiply by 1, and we have more noise. So the bigger age, the more noise we have. Let me again, maybe I want to reset simulation. I know that I don't change mainnet, but I think it's too much. Let's say 2. No. 0.2. Yeah, that's better. So now at the beginning, maybe in a few frames, we don't have a noise. And then this noise will be bigger. Maybe 0.25. Need to find the proper value. Okay, that's gonna be good, yeah. So that's look now more interesting. And go next thing I want to add here is using the volume rasterize attributes. So I want to create those attributes, and again we can simply go over each point and create the density attribute for all points. But another thing, interesting thing, what I want to do, I want to create the density attribute again, maybe based on the age of our particles. So let's go here to my noise. Oh, let me add another one attribute pop, because I want to put all inside of one attribute pop, and that's going to be set density. Okay, here are my particles, and also I have the age of my particles. So let me understand what I want to do. The same fit node again, we can use the fit range and take my particles, take my age from particles. And also I can take some random values from my point number, or from let's say for each particle is using my old ID. So let's, oops, not you. Let's bind here my old ID, which is integer. And I'm gonna use this integer for the random values. Okay, so for each point I will randomly create the values between 0 and 1. Well, 0 and 1 is not what I want to have. I don't want to have a value closer to 0, I guess. I hope I don't need to do this. So let's set like 0.5. So the minimum value is 0.5. Okay. So now we use this fit node, and let's multiply it by this random value. Here and here. So the fit node also, let's say like 5 seconds again. So again, depending of the age of my particles, I'm gonna apply this amount. And let's what else I can do? Let's bind export. Let's look at the density. So density, and the product of this multiplication should be a density. So go to here and multiply the density, normalize. Well, the p scale is not very good, like 0.1. Oh yeah, that's much better. Let me just decrease the voxel size because it's looking not very good. I guess that I need to decrease the voxel size even more, but in this case, yeah, it's looking good. Maybe for rendering, I will decrease it to 0.025, something like this. But now it's look not bad. Some kind of noise, and the smaller density in the beginning and the bigger density at the end. Like we did with the noise, we apply almost the same structure to the density. All right, but in this case we don't have like a glowing sphere in the beginning, because those smoke trails should be created from some sparks or firing objects, hot objects. So if you use a volume visualizer, look here, here's our density. We can select the density and density here and here. And with an emission, we should have some kind of, I don't know, the temperature or something like that, but we don't have this field. So let's set a fuel. Let's say, not fuel, burn. Let's set a burn field. And let's visualize this burn, but we need to create this burn field, and we're going to use almost the same system we have here. So let's set a fit range. But in this case, we need to create a very low range because I want to set the glowing just in the very beginning of the simulation. So let's make it, I know, 0.1, 0.2, something like this. Just to test, I will make it bigger, maybe, and bind export. Let's set the burn field, or flame field. It doesn't matter how you call it. You can call any word, burn. Or let's say the temperature. You know why? Because with the Because with the shaders it will be a little bit more simpler to identify the proper field for emission. So let's say temperature, and let's go here and select, oh yeah, need to command, we need to change temperature here, and let's visualize this temperature field. And maybe create it more with more brighter areas, or here also temperature. Let's make the red orange color like here. Do we see something? Let me scale the emission to, and for understanding, okay, so we need to create much smaller, come on, not you, much smaller attribute, I mean the much smaller range for the temperature in this case. So let's set 0.02 and 0.1 maybe. And yeah, I need to change my destination because I want to have 1 in the beginning and 0 at the end. So all values more than 0.1 will not produce temperature, and all areas between the 0.2 and 0.02 and 0.1 will do this. So maybe increase it to 0.5. Let's make it 0.75. Come on. Let's go to 100. The emission range, use the same, and I increase temperature even more to 1000. Now we can see that we have some information inside. Anyway, we can play with this information with shader on the render stage. So now you can see we have some nice fire trails. So yeah, now what I need to do is now cache this information. Let's name it trail render, and I'm gonna store this. Definitely to increase the amount of voxels. So let's write the amount of voxel to 25. By decreasing the size, you can see it's more like a blurry result, more better result, I hope. So the particle scale maybe a little bit more like 0.12. Just make this more wider. Yeah, it's looking nice. Cool, and let's store this guy beginning from frame 25 to 100. Go to geom, and that's gonna be my trails out trails. All right, so finally we now go to the rendering. So let's combine it into a group, call it trails, and let's set a color. What we left, the red one, right? Yeah. Okay, I'm gonna start this like additional element version 4. So now we can see all those 4 additional elements we have in one. Note, again, it's up to you. You can separate them into the different geometry, especially if you want to render them in this scene. So we can definitely work with the shaders, especially for each part of this simulation. And well, you can apply material for each element. But anyway, more interesting is to separate them into the separate geometry. But in our case, this scene is just for simulation. For rendering, we can create the separate render scene, because I want to have the renders here scene the lowest. I mean the work with resources. I don't want to have any heavy nodes inside of this. I don't want to have any simulation in my render scene, especially when I work with the complicated objects, with many simulations, with many objects. In rendering scene, I'm gonna have just a result of all simulations on this thing. Okay, so I can play with lights, I can play with shaders, I can play with rendering setup, and all my simulation will be in separate scene. For me, it's more better way to work. It's up to you. You can choose any way you want. You can choose. You can create any new scene for simulation and rendering. Let's say for RBD simulation, you can create a separate scene and make rendering on this. But anyway, if you create many different elements, we need to combine them on rendering stage. So even if you render like geometry from RBD simulation, you need to add explosion and fire, because you want to have the light from those explosions. You need to have the shadows from the smoke. So that in each of your scene, you will need to import all simulations from all your from all your simulations. So that's why I prefer to create a separate file when I want to combine those caches.